Your computer uses a network interface card to communicate with other computers. A network interface card for short is called a NIC, and I'll use that term quite a bit. Alternatively, you may see or hear the term network adapter, and that's also used frequently, but they're all used interchangeably to mean the same thing. The bottom line is we want to find what network interface cards we have on a particular computer, and so we can do that in Windows either with a GUI or a command line interface. So let's look at the GUI approach first, and we'll go to Control Panel. So once we're at Control Panel, we click on Network and Internet. We click on Network and Sharing Center, and we click on Change Adapter Settings. Now the reason we're going here is because then this will show us all the adapters or NICs that we have on the computer. In this case, the first one listed here is for a wired connection. So if we had a cable coming out of the wall, such as a Cat5 or a Cat6 cable, then this would be the NIC that we would plug into. So this is actually a physical NIC. This is also a physical NIC, but this is used for Wi-Fi connections. So if you have a wireless connection, this one is a virtual NIC, which means it's kind of fake. It's basically software emulating a network interface card, and it's used for communicating with the virtual environment we have on this computer. Okay, so if we want to look at, so we saw that it took quite a few clicks to get to that information. We could use a command line to get to that information maybe a little bit quicker. So if we open up PowerShell and run the get net adapter, in this case I'm going to use the dash name and with the star, and that's going to give us everything. And as you'll see, it gives you a lot of information. Now if you wanted to have a little bit cleaner picture, you could just select an object. And so in this case, one of the field names is name. So what we could do is just run the same command but select only that one field, and then we would see that we have our 3 NICs listed here. So that's a couple ways to get to that information on the Windows side. Now let's switch over to Linux and see how we could do that. And we're going to use Ubuntu to do that. Okay, in Ubuntu, we can use the IP commands. So the first one is going to be IP link. If we click on that, we see that we have 2 NICs, or 2 network interface cards, and they're labeled number 1, number 2. The first one is a loopback interface, and that is really just for internal communications within that same computer. The one we're more likely interested in is the second one, which is labeled ENP0S3. Now the naming convention is beyond the scope of this course, but just know that that's the name that you would use if you were running some other commands specific for that NIC. So if you were looking to get the status of the NIC, or you were going to enable or disable it, that would be the name that you would use in those other commands. So let's clear this up, and I'll show you one other. So the next command is, it's still an IP command, but it's IP address show. And here you can see it gives you the same information. Here's the first NIC and the second one being labeled ENP0S3. So there are other commands for getting to this information. There's more commands listed in the reference guide, but I think this will give you a good idea of how to get to this information. And to summarize, the reason you'd want to understand what NICs are on your computer is that if you're having some network communication problems, you need to first identify what NIC you're using or what NICs are available, and then you can begin troubleshooting from there. After you've gathered information about the network interface cards on your computer, the next step may be gathering information about the MAC addresses. Now the MAC address could be used to, say, restrict certain computers from gaining access to a Wi-Fi network. So there's various uses for the MAC address. But before we go in and find that information on our computer, just be aware that there's several terms that could refer to a media access control address or a MAC address. Physical address, hardware address, and link are all different terms that all basically relate to MAC address. So you're going to see that in some of the commands here. So let's look at Windows, and we'll go through the GUI to find this information. We're going to Control Panel, Network and Internet, Network and Sharing Center, and then Change Adapter Settings. These are the same steps we took to find the NICs in the first place. Now if it's been enabled and you double click it, you'll see the Details tab. Click Details tab, and then you'll see the physical address here. Starts 0A0027. I'm going to move that to the side for a second. Now if we want to get the same information from a command line, we can open up a command prompt and use the ipconfig all command. You'll see that a lot of information scrolls by, and it's probably too much information to really deal with all at once. What you can do alternatively, as a side note, is run that same command but pipe the output to another command called more. When you do that, it will display one page of information at a time. So let's try that, and now we see the first part and it doesn't scroll all the way past. Now if you want to move down one line, you hit the enter key, and if you want to move down another screen, you hit the space bar, and if you want to get out of this, you just hit Control C. We'll have a little bit more on that later, but this is just a side note for your information. So when we double clicked in our GUI on the virtual NIC and found its MAC address here, we can get that same information here. So here's the virtual NIC and here's the physical address, again 0A0027, etc. See that it matches up. Now what you noticed is when we went through the GUI approach, took quite a few clicks to get to the information, and it was kind of buried. When we use the regular Windows terminal, there's a lot of information, it's a little bit cluttered. So if we use PowerShell, there's a command called get net adapter, and we can select just the name and the MAC address. So we'll get the name of the NIC and the MAC address. And if we do that, we see that it's a lot cleaner and it's very easy to get to. So this might be the approach that you'd want to use in this circumstance. Now if we look at Linux, specifically Ubuntu, we see that if we run the IP link command, then down here for our second NIC, the MAC address is actually referred to as the link. And if we went to the GUI and we went to network and then clicked on the wired NIC here, we see that it's referred to as the hardware address. But again, the numbers are the same, 080027. So these are just a couple ways to get to the information. It can be confusing because different terms are all used to refer to the same information, but as long as you're aware of that, then I think you'll be fine going forward. At this point, you know what NICs are on your computer and you know the associated MAC addresses. Now we're going to find the IP address. The IP address is something you'll use probably most often as a system administrator or an information security tester. And so we're going to follow some of the same steps that we did when we found the MAC address. So this might seem a little bit redundant, but I think it will help drive home the point that if you know a few commands, you can get a lot of information. But we're going to break it down into individual components. So we first looked at the NICs, then the MAC address, and now the IP address. So let's go back to Windows Control Panel, go to Network and Internet, Network and Sharing Center, and change adapter settings. Once again, this is where we found what NICs we had. We click on one that's enabled, double click it, and go to Details tab, and this is where we found our MAC address, or the physical address. Now if we go down a little bit further, we see the IPv4 address here, 192.168. Okay, so we could also find, and notice it's .56.1. So when we go to our command prompt here, and we go to ipconfig, and we look at the virtual NIC, the VirtualBox NIC, we can confirm here that we have the IPv4 address as 192.168.56.1, and alternatively we could use PowerShell. and we see we get the same information for our virtual host NIC. Okay, let's go to Ubuntu now. Now in Linux, or in this case Ubuntu, we can use the IP address show command. If you run that, and then we look at our NIC here, and recall that the link was our MAC address, and the inet is our IP address. So this is the IP address that was assigned when we joined that virtual network. Okay, now that's probably the best command to use in Linux to get the IP address. It's an easy one to remember because it just says IP address and then show, and so that's one I would recommend using. I want to finish this section by just making a couple points. Number one is an IP address can be assigned manually or dynamically. Now the reason you'd want to assign it manually is so the IP address would be static, that it wouldn't change over time. And this is good when you're assigning an IP address to a server, because you don't want people trying to guess or figure out where the server's at. If you have a web server and you're trying to access a web page, you want it to be in the same place all the time, so you need to have a static IP address, and in those cases you would assign it manually. Alternatively, or conversely, a client's IP address doesn't have to be static, and so something can be set up called a DHCP server that would assign just a random IP address to a client every time they join the network. So they would have the ability to be a part of the network. It's just that their IP address potentially could change each time they log in. So these are just a couple points to be aware of as far as IP addresses are concerned. Over the last few sections, I've used some skills or techniques for manipulating the command line, or the commands on the command line. I wanted to focus in on those things because these skills can be used in Windows and Linux environments when you're using the command line interface. So the first one is the recall last command. Now as you type various commands, a history will be saved, and so if you use the up arrow, you can go back to previously typed in commands, which means it'll save you a little bit of time from typing. The second skill was redirecting output, and that is where we use the pipe to take one command and send the output to a second command. And we've seen this when we were using the more command, which is the third skill that I wanted to bring up, and that is where you pipe your output to the more command. The more command will display one page of information at a time. If you hit the enter key, it will scroll down one line, and if you hit the space bar, it'll scroll down a full page. And then if you wanted to exit out, you could just hit Control-C. So I'll use PowerShell to demonstrate this. Okay, so here's a command, getnet IP configuration, and when we run it, we see a lot of information, and some of it scrolls off the screen. So if we do the up arrow, that recalls our last history. I can go back to a previous command, which was CLS, or clear the screen, and that clears the screen up as it is intended. So I can go up again, and now I can recall a command that I previously typed, which was the same command, but it was piped to more. If I run that, then I get one page at a time, and as you can see at the bottom, it says more. So if I hit the enter key, I'll go down one line. If I hit the space bar, I'll scroll down one page, and in this case it goes to the very end. And if I hadn't gotten to the end and I wanted to quit, I could just hit Control-C. So once again, I wanted to focus in on these specific skills because I used them in previous sections, but you may not have picked up on the actual skill or technique for what was going on. It's not just a matter of running a command, but having several skills to be able to effectively run a command. The next concept to discuss is DHCP server. DHCP stands for Dynamic Host Configuration Protocol, and it's really a tool for a system administrator to be able to push out configurations to client computers. So things like the IP address, the gateway, the DNS, all those configuration settings can be pushed out from a DNS server, but of course the DNS server needs to be set up in the first place by the system administrator, and that part is beyond the scope of this course. From the client side, however, we can determine if our computer has been set up or enabled to use DHCP to retrieve the IP address. So we can do that in several ways, but first let me just recap. There's two components to DHCP. Number one is the DHCP server itself, and that would be beyond the scope of the course. And then on our client computer, we can see if it's enabled. So using these commands, such as here in the Windows terminal, the ipconfig command, we can scroll down and see that DHCP enabled field says yes. So for this particular NIC on our computer, DHCP is enabled, which means it's going out to a remote server to obtain its IP address. Okay, we can find that information in PowerShell as well, and some other commands listed in the reference guide. But let's jump over to Linux real quick. Looking at Ubuntu, we can go to the system settings, and if we go to this NIC, the wired NIC here, and go down to options, then we can go to the IPv4 settings tab, and here we see that the method is automatic DHCP. So this indicates that this NIC, or this network interface card, is also using DHCP to obtain its IP address. So here's this is just a concept to be aware of. More than likely, a lot of this stuff just kind of runs automatically, and if you've enabled DHCP, there's really not much more for you to do. Everything will be pushed from the DHCP server down to your client computer, and that would allow some configuration settings to be set so that you can communicate with other computers on the network and connect out to the internet. The next concept we'll talk about is the gateway router. Now, up to this point, we've really been assuming that everything that we're doing is on the specific network that we happen to be on. So our DHCP server and the MAC addresses and the IP addresses, it's been kind of the underlying assumption that we're just talking about the network that we're currently on. Now, if we want to communicate with a computer that is beyond our network, we need to go through a gateway router. The gateway router is more than likely a network device that's dedicated for communicating between two different networks. So the gateway router would actually have two NICs on it. One NIC would point towards the network that you're currently on, and then the other NIC would point towards another network, such as the internet. So if you're having a problem getting to the internet, this is one of the troubleshooting steps that you would go through to see or to identify whether or not a gateway IP address has been assigned. So there's several commands that we can run. We'll just run through a couple here because a lot of the commands are very similar to what we've already run before. So again, the ipconfig all, find the gateway. This again, we're piping the output to a new command, find, and we're just trying to weed through all the clutter. So we just find gateway, and here we see what the gateway is. Jumping over to Linux, I want to show you Ubuntu and CentOS for this time. Now in Ubuntu, we can just run the netstat-nr command, and here we see the gateway is listed here. In CentOS, we run a different command, and this is the nmcli command. Now again, when we identified our NICs, remember that the one NIC we saw was ENP0S3, and so that's the value we would put here. So this nmcli connection show, this is the NIC that we're interested in, and then we're going to grep. This is kind of like the find command in Windows. So we're going to grep and look for the term gateway. This -i just makes it case insensitive. So when we do that, we see the IPv4 gateway. Now in this case, a gateway has not been assigned. In CentOS 7, by default, the NIC is not enabled. So we'll have to do that later. We're going to use this a little bit later in some troubleshooting. But in this case, we can see that there's no gateway assigned, so we wouldn't expect to be able to get out to the internet. And we can prove that by doing a ping command. And this is just trying to see if we can get out and see. You see an error message here, network is unreachable. So again, it's important to understand the concept of a gateway router, which is to be able to bridge the gap or bridge two networks so that you can communicate from one network to another, and to understand where to find that information in case it's missing. Then you'll know that that might be one of the reasons you can't communicate or reach another network. We've talked a lot about the MAC address and the IP address, and these are really good numbering systems for computers to communicate with each other. But for us as people, it's not very easy to communicate by remembering a bunch of numbers. It's much easier for us to remember names. And so there's some mechanisms that can translate names into numbers. For example, if we went to google.com, there are some mechanisms that would translate that name into an IP address, and then from there the computers would communicate based on that number or that IP address. So a couple places that this translation can occur is number one, on your local computer in a host file. And I'll show you where that is on a Windows and Linux machine in just a minute. If that translation is not found in the host file, then it'll consult the DNS server, or the domain name system server. And this is a remote server that will look up that translation. If it doesn't have the translation, it will ask another DNS server if it has the mapping or the translation, and so forth, until it's found, and then that IP address will be returned. So now let's take a look at our Windows machine, and we'll see where that host file is. We're going back to step one. So the host file is actually buried pretty deep. Let me go back to the reference guide here. And in the reference guide you see that it's a long path, and if we go out to the command prompt, then I've just typed that in, and I'm using more as the command, and I'm looking at this file in this directory. So I'm looking at C Windows System 32 drivers etc. That's the directory, and then the host file. And when I look at the file, I can see this mapping. Now this pound symbol out here is a comment, so this is actually just an example. It's not active, it's commented out, and it's just there for reference. But you can see this is the format it's expecting. So if I asked for rhino.acme.com, the host file would translate that name into this numbered IP address. Okay, on the Linux side of things, we'll look at the Ubuntu machine or computer, and its host file is under the etc directory. So I'm going to use the command more, look at the etc directory and the host file. So if I do that, we can see a similar format where you have the IP address and then the name. So in this case, there is no external or remote computer listed here. So if we were looking for google.com and it looked in this file, it wouldn't find it, so it would go to the next step, which is to look at the DNS server. Okay, so we need to configure a DNS server on our computer so that our computer knows where to look. Now, if that DNS server is not configured, then we might have a problem looking for google.com, or we wouldn't be able to, there would be no mechanism to translate it. Now DNS, I think I mentioned, if it doesn't find the translation, it will ask another DNS server, and that's all built into its protocol. And at this point, we're just looking to see what DNS server is configured on our computer. We're not trying to configure it. We're just looking for the information at this point. So if we go out to, or go back to our command prompt, and we can find in our ipconfig, we've seen this command before, and instead of looking for the other information, we'll look for DNS servers this time. And here we see it's listed as 8.8.8.8. If we go to our Ubuntu machine, clear this up, and we'll run this command. The DNS server would be identified in the etc.resolve.conf file. So etc. Okay, so cat is another type of command that will display a file. Before I used more, I could use either one. This is the directory etc, and then the file is resolve.conf. This is the DNS server, and this is the IP address of the name server being the DNS server. So let's recap a couple of ideas. The first idea was that there are two places that the name to IP address translation can occur. The first place was on the host file on your local computer. If that translation can't be made there, it will go to the DNS server, and that the DNS server has a hierarchy built in where it will ask other DNS servers for that translation if it doesn't have it. Finally, if you're searching for a computer by its name and it can't be found, but you know that the computer is out there, you can still access it by the IP address. Up to this point, I've been typing in commands and showing you the output. So now let's take some time for you to do an exercise. And in this exercise, you'll be typing in the NSLOOKUP command and providing a website URL. And then in return or in response, you will be getting the IP address. And this is called a forward DNS lookup. We could also provide an IP address and get the name back, and that would be a reverse DNS lookup. But let's just focus on this part of it where we're providing the name, because that's typically what we'll know. Okay, we can do this at the command line, and here is the Windows command prompt. So the command is NSLOOKUP, and then we provide the name of the website that we're looking for. This info, I'm not trying to push any particular website here. You can use any website you want. It's just one that I've used before. So you hit return, and then you'll see that the IP address that's associated with that name is provided here. Now if we go over to Ubuntu, it's the same command, same website, and we get the same information. So a couple things to note here is that this NSLOOKUP command is used on the Windows side and Linux because it's more of a network-based command, not really operating system related. Here's another information security related website. We can do that over here as well. Okay, and we can compare the two, see that they're the same. So anyways, this is just a brief exercise that you can put in whatever website you would like to see, and you could look up the IP address. But just to go back to the previous point from the last section, all you really need to know is the name, and the computer behind the scenes will take care of looking up this information, looking up the IP address, and then using that IP address for further communications. Okay, let's go ahead and wrap up this section, and we'll do that by just reviewing some of the skills and concepts we learned. So first of all, let's take a look at the command line and recall the skills that we learned. One of them being that we could use the up arrow to scroll through some of the previously typed commands that we had entered, so that saves us a little bit of time from retyping the commands. We also learned that we could use this pipe here to redirect output from one command to another, and we would typically redirect the output to something like the more command so that all the information wouldn't scroll off the screen. If we wanted to filter the data down to be a little bit more specific to the information that was returned, we could use things like the find or the find string, or in the Linux case, we could use grep to filter out some of the rows. And we provide a term such as IPv4 address to filter out the information that was returned. We could also, in PowerShell, use the select object to filter on the fields that were returned. So that's briefly some of the skills that we learned. And now let's take a look at the terms and the concepts. So we started out with learning about a NIC, and we worked our way down to the DNS server. So let's kind of work backwards a little bit. When our computer joins a network, we need an IP address, and so we can get that by going to the DHCP server and requesting an IP address. Once we get that, now we can make requests to other computers because we're on a network. If the request we make is to a remote server, then generally we know the name. So we put out a request out there and we say we want to send this request to, say, Google or whoever. Well, we give it the name, and the name, our computer takes the name, goes out to the DNS server and says, here's the name, we need the IP address. And the computer gets the IP address back. Then the computer takes that IP address and sends it to the gateway and says, hey, this computer, this remote server is not in our network. It needs to go to another network, and the gateway will know how to forward that request on. Eventually, that request gets forwarded to the network that the destination server resides on. Once it gets into that network, then another translation will occur. That IP address will get translated back down to the MAC address, and then that request will eventually get to the NIC and the computer. The destination server, will process the request and then send a response back. So hopefully this list of terms and that description will help you understand how these things interrelate with each other and where they play. You might hear the terms and just not know where they fit into the big picture. So hopefully that little description will provide that. Now, a lot of these things you won't really need to know too much about because a lot of that infrastructure is already in place, and you really just need to provide. Like you just have to identify the DNS server and the gateway. A lot of the communication that goes on behind the scenes is already set up, and you don't really have to get involved in that. It's almost like sending a letter through the mail. You put a request in an envelope. You put the destination address on the front of the envelope. You drop it off at the post office, and from there, all the infrastructure that gets that letter to the destination is something that you don't see or even really care about. You just know that you'll get a response back at some point in time. Same thing with the computer. You just provide the destination, and the infrastructure will handle it from there.